In this video, I'm going to talk about the different modes of heat transfer. What is heat transfer? If you have a cold object inside a hot environment, heat will travel from the hotter body to a colder body naturally, and you don't have to do anything about it. This is the second law of thermodynamics, which is also a natural phenomenon that we can observe. So for example, if the environment is around 50 degrees Celsius and you have a cold object 20 degrees Celsius, so what will happen is heat will transfer from the hotter body, which is the 50 degrees Celsius body, to the 20 degrees Celsius body. And if heat transfer takes place long enough, both of the temperature will reach to a equilibrium. That is when heat transfer will stop. So maybe after 1 hour or 2 hours, they come to a same temperature of, let's say, 35 degrees Celsius. Similar to traveling from, let's say, point A to point B, there are different modes of transport that we can take. For example, we can take a bus, we can take a train, etc. As for heat, when heat need to move from point A to point B, they can go by different modes as well. So mainly there are three modes of heat transfer, that is conduction, convection, and radiation. And one mode of heat transfer may be more obvious in certain situations compared to the other. Now let's talk about conduction first. Conduction is the transfer of heat in a solid, liquid, or gas, but it is more predominant in solid, when the molecules and atoms are closely packed together, and heat will transfer from one atoms to the other by vibrating from side to side, by colliding with the molecules at the side of it. So heat will slowly transfer from one end to the other end. And there's a formula for that. The formula is Q is equal to negative Ka dt dx. Q is the heat transfer rate. Heat energy is in joules. Heat energy is in joules, and when there's a dot on top, it means flow rate. So how fast energy is moving is joules per second, and that's the reason why the units for Q dot is watts, as you can see from here. So it's the heat transfer rate. K is the thermal conductivity of a material. So for example, if you have a piece of metal, if let's say it's a steel or a gold or silver, there will be a different thermal conductivity. So it depends on how well it can transfer heat. And if you have a piece of wood, or we are talking about air, the thermal conductivity, this K value will be different as well. And the unit is in watts per meter Kelvin. So it means how much heat it can pass per meter per Kelvin. A is the area of the surface that we are talking about. Let's say from point A to point B, and this will be the cross-sectional area that we are interested in. So that refers to A. dt dx is the difference in temperature per unit length. dt is the difference in temperature. Let's say from point A to point B, it will be temperature at point B minus temperature at point A. So this is the delta T, dt. And what is dx? Dx is the difference in distance. So if this value is x, that will be dx. So distance at B minus distance at A, that will be dx. So dt dx, we also call it the temperature gradient. In cold countries, usually you'll see people wearing this type of jackets. So why is this jacket so commonly used? It is because, as you can see, this type of fabric or this type of clothing, it is able to trap a layer of air within it. So all these are air pockets that makes the jacket look very fluffy. And as we know, air is actually a very bad conductor of heat. So if you have a layer of air that is surrounding you, heat from your body will not be lost to the surrounding that easily. So because of this, the K value of your shirt become much higher. And therefore, heat transfer by conduction from your body to the surrounding will be reduced. So let's take a closer look by examining a piece of rod which is heated up on one end. So this point is the hot surface, let's say 50 degrees Celsius. And at the other end, At the other end, it may be around 20 degrees Celsius. So over here, there's a temperature difference. Why is there a negative sign added in front? Because this Q refers to the amount of heat that travels away from it. So dT dx is the temperature at the other end minus the original point of reference temperature. So over here, the point of reference temperature is 50 degrees Celsius. So delta T will be a negative value. So dT dx will be a negative value because it will be 20 minus 50. And when it multiplied by the negative sign in front, it will become a positive value. So it means it will tell you how much heat actually flow through it and flow away from this particular point of reference. If let's say the piece of rod is made out of 3 different materials with 3 different K value, and the temperature gradient will be different when heat started from this point, which is the point of reference, let's say 50 degrees Celsius, all the way to the end, 20 degrees Celsius. But however, if let's say K1 is a certain material that is able to conduct heat well, the temperature gradient will be much more gentle. As heat travel along this rod, the temperature will change accordingly depending on the K value of the particular section of that material over there. So let's look at one example. If we have an example which is similar to the diagram before, and let's say the point of reference is here, and you heat up this particular region, let's say to 50 degrees Celsius. So as it travel, so from the start of point 1 to the end of point 1, the temperature only dropped by a little bit. So let's say it is 45 degrees Celsius. At the start of point 2 to the end of point 2, the temperature dropped by a lot, as you can see from here, T2, the start of T2 and the end of T2. So let's say over here is around 20 degrees Celsius. And finally, from the start of material 3 to the end of material 3 is another gentle gradient, so maybe around 10 degrees Celsius. So what they want to find out is which material acts as the best thermal insulator. So as you can guess, if it is a good conductor of heat, the temperature will be quite close to each other. So for example, this is 50, this is 45. It means that heat can travel easily past this particular section, this material 1. However, for material 2, the heat is not able to transfer that easily. That is why the temperature gradient is much greater. So we can guess the best insulator is actually material 2. If you look at the formula, Q is equal to negative Ka dt dx. Temperature gradient is dt dx. If Q is a constant number and dt dx is very high, then your K value has to be very low. So for the case of point number 2, material 2, dt dx is the highest. So on the other hand, its K value will be the smallest. And the smaller is your K value, the insulation properties will be better. Next mode of heat transfer is convection. The difference between conduction and convection is convection will only happen in fluid. It can never happen in a solid because it needs the molecules to travel. So when you heat up the bottom of let's say a pot of water, the bottom of the fluid will be heated up first. So the molecules below will have higher energy, and it will start to move upwards. This will carry heat together with it, and the cold fluid will start to flow down to displace the hot fluid, and you will get a current called convection current. This is the formula that governs the amount of heat transfer by convection. Q is equal to HA Ts minus T infinity. H is the heat transfer coefficient, and the value will depend on the type of fluid that is carrying the heat. So for water, for oil, for air, it will be a different H value. A is the area of the surface. Ts is the temperature at the surface. So Ts, let's say this temperature surface is around 80 degrees Celsius, And T infinity will be the fluid temperature, let's say around 30 degrees Celsius. So the bigger is the difference between these two temperatures, the higher will be the rate of heat transfer by convection. This is called a stack ventilation. So how it works is, during the daytime, it will heat up the air pockets inside the building over here, because over here this is a piece of glass or it's a skylight, so heat will be trapped inside and air will get heated up. And when air get heated up, it will start to move upwards because it will become less dense. So the cold air will start to displace the hot air, and there will be a movement of air. So this will create a natural ventilation effect, and that is why it's called a ventilation stack. The last mode of heat transfer is by radiation. So radiation will occur even in a vacuum. It does not need any molecules, the solid or liquid or gas type of molecules to help to transfer the heat, and heat will just travel from point A to point B without any medium. An analogy, let's say a person at point A want to pass something to point B, he does it by throwing the object over. Whereas for conduction and radiation, for conduction and convection is slightly different. Conduction will be the person will pass it to the next person, and will pass it to the next person, and this is conduction. As for convection, it is just like the person walking to the person B and pass the object to B. So radiation, as you can see, it does not need any help in between, and you will just throw the heat over to the other side. So what is the formula that governs the heat transfer rate by radiation? It is epsilon sigma A Ts to the power of 4 minus T infinity to the power of 4. Epsilon is the emissivity of surface, so it depends on whether the surface is rough or smooth. Okay, whether is it rough or smooth, and what is the color of the surface. So it largely depends on these two factors, and it's always between 0 to 1, where 1 is when it's dark and it's very rough. Sigma is a constant number. It is Stefan-Boltzmann constant, and it's 5.67 times 10 to the power of minus 8. Ts is again the surface temperature. So let's say 50 degrees Celsius, and T infinity is the temperature of the surrounding. So let's say 20 degrees Celsius. But the difference between convection and radiation, you are not going to just take the delta T like this. You have to make the temperature to the power of 4. So if it's to the power of 4, you cannot just use degrees Celsius. You have to convert the temperature to Kelvin. So degrees Celsius convert to Kelvin, you have to add 273 to make it into Kelvin before you take the value and to the power of 4. We are often advised not to wear black or dark colored clothing for hot climates. Why is that so? So the main reason is because dark clothing has a higher emissivity. So when there's a higher emissivity, heat will be able to enter the object more easily by radiation. If you are wearing a dark color shirt compared to a friend who is wearing a plain white color shirt, you will feel hotter because you will be able to absorb more heat. How about during cold condition? Let's say you are in a cold country. If you wear a dark color shirt, heat on the other hand will transfer from your body to the surrounding via radiation more easily, because emissivity works both ways. A good absorber will be also a good radiator. Chances are you'll feel colder compared to a friend who is wearing a plain white shirt. How does a thermal flask work? If you have seen a thermal flask before, usually you'll notice that the surface of the flask is light in color or very shiny, like silverish in color. And that is to reduce the emissivity value, such that radiation will not be able to, heat transfer by radiation will not be so easy. Then next, there's beneath the surface, there's a layer of vacuum or a layer of air that is to reduce heat transfer by conduction. because the K value will be largely reduced due to the vacuum. And lastly, you'll notice that the cap and the bottle will be very tightly sealed, and usually you have an additional cap to have that additional layer of protection to prevent air from getting in. Because once air is able to get in easily, then heat transfer by convection and conduction will be possible.